Hi everyone, thanks for joining in. So my name is Aadithi Gopalakrishnan, and I'll be talking about my work on estimating the abundance of the critically endangered straw-headed bulbul using passive acoustic methods. And my supervisors are Ryan Chisham and Saugata Sadukan, and my collaborator is Tak Funk. So, just a brief introduction. The straw-headed bulbul is critically endangered due to the songbird trade that happens in Southeast Asia. So, these birds are highly valued for the duets that the male and female sing together. So, poachers usually catch them to enter them into song contests. So, the idea behind this was to use the very vocalizations and songs that have led to their decline to aid in their conservation. So, we deployed passive acoustic recorders in our study area to record these birds for a week in each location and for 6 hours on each day. And we also looked at the habitat preference of the species and accounted for it in our abundance estimates. So our main objectives were to train a classifier that was able to detect the Straw-headed Bulbuls vocalization specifically. So this was done using important signal parameters by studying the bird's vocalizations in detail. And we also obtained the song rate, which was an important input for our model. And we accounted for the habitat preference of the species by collaborating with experts from the Avian Evolution Lab at NUS. And finally, we built a robust statistical model for our abundance estimation. So the study area was Pulau Ubin. It's a small island off the northeastern coast of Singapore. It's around 10 kilometers square. And this is speculated to have the highest population of straw-headed bulbuls in the world. So we deployed recorders all across the island in these grids. Each grid was 500 into 500 meters square. So we have these recorders recording these birds, but how do you convert the acoustic detections to a spatial distribution? So for that, these were the inputs that were fed into the model. One was the detection rates across Pulau Ubin, and for the detection probability of the recorder, which was a key input, which converts acoustic space to a spatial distribution. We used an array of 5 recorders in one of the grid cells and used the principles of acoustic spatial capture and recapture. And finally, we calculated the average song rate by tracking a pair in their home range and by setting up 8 recorders around them so that a dynamic combination of recorders would catch all the vocalizations of the bird for that 1 hour. So, what is the broader scope of this work and what can it be used for in the future? The first thing we're looking at is the population viability analysis, where we're planning on using this population that's doing well in Pulau Ubin to as a test bed to check how the populations are in other countries and how long it would take for the birds to go extinct. So we're looking at survival rates, clutch size, and mortality rates. And another thing is the government initiatives that have been set up for the species. There has been a grant from the Ministry of Education to look into the viability of straw-headed bulbuls. And there's also a national species action plan that focuses on conserving the species. And it's doing well in Singapore because of the strict anti-poaching policy. So that's something that they want people to have awareness about. And some of the management strategies that can help with our understanding if Pulau Ubin as an island has reached its carrying capacity because it's harboring the world's largest population, and how to connect this population to the mainland or elsewhere. And for that, they'll be looking into the genetic viability of the population. And finally, for the global impact, this our main goal is to look at the tolerance level of poaching that can prevent the species from going extinct, and also the minimum viable population that will be needed, as well as awareness and implications of the songbird trade. So to conclude, I'd like to say that we were able to get the population assessment as well as the habitat preference of the species. And using acoustics is still pretty novel in this field, especially to estimate the abundance. And there are very few studies that are able to do it using only acoustics because it's usually a combination of acoustics as well as visual surveys. And The study also has global conservation implications because the message is to put it out there that this is a critically endangered species and it's doing well even in a slightly urban environment, but without any poaching. So it's okay if you don't have the most pristine environments, but you can still conserve the species by using strict anti-poaching policies. So thank you.